Bismillahirrahmanirrahim. Again, I welcome you to the course of the Engineering Dynamics. So this is lecture number 7. In the last lecture, I have discussed the projectile motion and detail of all the time to reach the maximum height, horizontal range, time to reach the total flight, and the trajectory, and solve the two sample problems. Today, I solve some unsolved problems related to the projectile motion. This will help you how to tackle the problems regarding the projectile motion. This is problem 2-62 of Engineering Dynamics by J.L. Merriam, 7th edition. A particle which moves with a curvilinear motion has a coordinates in millimeters which vary with the time t in seconds according to x is equal to 2t square minus 4t and y is equal to 3t square minus 1 by 3t cube. Determine the magnitude of the velocity v and acceleration a and the angle which these vectors make with the x-axis when t is equal to 2 seconds. So we have to, we can of course draw the trajectory with y and x coordinate that I have shown you earlier. Now we have given the x as a function of time, y is a function of time. So now the acceleration in the x direction is not 0, and of course the acceleration in the y direction is also not a constant value of g. They have given, so we use these relationships. We know x is equal to 2t cube minus 4t and y is equal to 3t square minus 1 by 3t cube. So let's take the first derivative of the x. We find 4t minus 4 is millimeter per second, and x double dot is again second derivative, which is 4 millimeter per second square. Remember that in this case there is an acceleration, constant acceleration, 4 millimeter per second square is given. So there is some force is in the x direction during the projectile motion. Similarly, y dot is 6t minus 30 square millimeter per second, and y double dot is the acceleration in the y direction, 6 minus 2t millimeter per second square. Now you see, in this case the acceleration in the y direction is a function of time. It is given to you, so you will not use g in here, you use the same acceleration. So at t is equal to 2 seconds, we are given what is the value at 2 seconds. I put the value of x is equal to 2 in the velocity x, the 4 millimeter per second, and in the velocity y I get the 8 millimeter per second. So the velocity vector is 4i plus 8j millimeter per second. The angle is tan inverse, of course, the y component over the x component, 63.4 degree. Similarly, acceleration, which is 4i, and if I put 2 here, so I will get that is 4 is 2. So it's 2j, and then the angle between them is 2 by 4, which is 6.56 degree. I summarize the values. This is the velocity vector, this is the angle, and this is the acceleration, and this is the angle made by angle of acceleration, which is 6.56 degrees. Now let's move to the problem 2-64. The y coordinate of a particle in a curvilinear motion is given by y is equal to 4t cube minus 3t square, where y is in inches and t is in second. Also the particle has an acceleration in the x direction also. We're given ax is equal to 12t in inch per second square. If the velocity of the profile particle in the x direction is 4 inch per second, where t is equal to 0, calculate the magnitude of the velocity v and acceleration a of the particle when t is equal to 1 second. Construct v and a in your solution. Of course, we need to find v and a. Of course, y, we have given y is equal to 4t square minus 3t. Right? So at t is equal to 0 and v naught of x, which is given to you, that is 4 inch per second. Initially, the velocity is 4 inch per second. I think it is given here. Right? It's a 4 inch per second. So yes, this is a particle is if the t is equal to 4 inch per second, right? So similarly, we have given the y dot. We take the derivative and we get the vertical velocity. This is 8t minus 3 inch per second, and take the second derivative, which is 8 inch per second square with the acceleration in the y direction. As we have given ax is equal to 12t, I need to find the velocity. So of course dv by dvx by dt is equal to ax. So by integrating here from 4 to v, because initial velocity is 4 in x direction and this is 0 to t, I get the vx is equal to 6t square plus 4 inch per second. It is in the question, it is asked that t is equal to, if t is equal to 1 second, what is the velocity? So it is 6 plus 4, 10 inch per second, and similarly vy is equal to 8 minus 3, 5 inch per second. So the velocity becomes 10I plus 5j inch per second, and the magnitude becomes 11.2 inch per second. Similarly, the acceleration, we have the acceleration in ax is 12t square, where t is equal to 1, is 12 inch per second, and ay is 8 inch per second. So this is 12I plus 8j, and the acceleration is 14.42 inch per second square. Let's see the problem 2-67. A roofer, if you see the roofer, a person standing here, tosses a small tool to the ground. What minimum magnitude of horizontal velocity is required to just miss the roof corner B? Also determine the distance B. We are given the coordinates with reference to the roofer, that is 2.4 in x and is about 1.2 plus 0.9, which is about 2.1 meter. So we know the coordinate, and we need initial horizontal velocity. For this case, we have a derived equation for the trajectory of the projectile. So y is equal to x tan theta minus g over 2v naught square sec square theta and x square. Here of course the horizontal velocity, the x theta is equal to 0. So x is equal to minus 2.1, right, downward, and x is y is equal to minus 2.1 and x is equal to 2.4. I put these values in this equation with theta is equal to 0. So this term goes to 0, this goes to 1, and g is 9.81. So here I put the value of course the x as well, and I can find the value of the velocity, which is 3.67 meter per second. You see, by using the trajectory equation, we know the position of y of x and theta. We find the velocity required initially to cross that particular point. Now we need to find distance d at which it strikes the ground, right? We need to find this point where it strikes the ground. So we need to find time for vertical motion, which is equal to the horizontal motion. Because the initial velocity is 0, it is half gt square. It is about 1.02 seconds to reach that particular point on the horizontal, that is point C. Now we can find the horizontal velocity. The 3.67 is of course the velocity, which if we find out 1.02 is 3.74 meters. And 3.74 meters minus 2.4 is the initial distance, which is this one, right? So this, we need only this distance, which should be subtracted from here, and it is 1.34 meters. So total distance traveled, of course, horizontal 3.74 with reference to the roofer, and of course the initial displacement of the corner is 2.4. So it's subtracted, we get the distance d, which is the second requirement in this problem. I hope you understand. Next problem is 2-72. The water nozzle ejects water at a speed of v0 is equal to 45 feet per second at an angle theta is equal to 40 degree. Determine where relative to the wall base point B the water lands. Neglect the effect of the thickness. The initial height is 1 feet, and we need where it strikes here at this point. The distance between them is of course 60 feet. This height is 3 feet. So we have given v0 45 feet per second and theta is equal to 40 degree. The horizontal range, if you need to find total range, so it's v0 square by g sine of 2 theta. By putting the values, you get 61.93. This clearly shows that it will hit hit the vertical wall at some height, because this distance is 61 feet and the horizontal range is 61.93 feet. Now the equation of trajectory y is equal to x tan theta minus g by 2 v naught square sec square theta x square. So we need to find y. What is the position of y when x is equal to 60? So I put the value of x 60, tangent 40, g is 32.2 in feet per second square, 2 into of course the 45 square velocity, and this is the angle of 40 degree and 60 square x. I find out it is 50.34 minus 48.7, 1.56 feet. Now if you see the initial vertical height which is given to you, it is 1 feet. So the required distance from the base of B is 1.5 plus 1, which is 2.56 feet. Because it is from here, so I have to add this one. So this should be 2.56 feet, which is the requirement. Now next problem which I have selected to solve is 2-75. The pilot of an airplane carrying a package of mail to remote outpost wishes to release the package at the right moment to hit the recovery location A. What angle with the horizontal should the pilot's line of sight? It's not the plane angle, plane is horizontal, and what is the line of sight of the pilot to the target, right, make at the instant of release? The airplane is flying at horizontally at an altitude of 100 meters, right, with a velocity of 200 kilometers per hour. So this is the plane which is moving in horizontal direction. At this position, the pilot saw the target, and we need this angle, what the angle of this line of sight made with the target. And it is the altitude of 100 meters. So we have given the velocity is 200 km per hour. So we have to convert first of all in meters per second. It's 200 in kilometers is 10 is power 3, and hour is 36 in a second. We get 55.56 meters per second. So let's see the first of all the vertical motion, because we can find the time, because initial velocity of vertical is 0, is of course the g, because it's downward, h is equal to 100 meter. I use the same equation as equal to vit plus half gt square, and we find the time which is 4.5 seconds will take. Take whatever the package from the plane to the target. Now the horizontal distance traveled, of course, v naught of t, 55.56, 4.51, is 250.6 meters. Now I find this distance, I have found out this distance, and this distance, which is 100 meters, given to you. I can find the angle by applying the tangent theta. Tan theta is equal to perpendicular upon base. It is 21.75 degree. This is the angle made by the line of sight of the pilot to the target. Now let's move the problem 2-81. The muzzle velocity of a long-range rifle at A, right, A is u is equal to 400 meters per second. Determine the two angles of the elevation theta which permits the projectile to hit the mountain target B. We can hit, of course, at this angle, and we can hit at this angle, right? We need to find two possible angles at which we can hit with the same velocity to reach that particular target, which is 5 kilometer in x, and of course the 1.5 kilometer in vertical. So we know if you see, we have the x and y coordinates. So if we put this and we have the velocity, so if you put in the trajectory equation, we will get a trigonometric equation, and by solving the trigonometric quadratic equation, we can find the angle. I did the same thing. We have given 400 meters per second, x is equal to 5 kilometer, y is equal to 1.5 kilometer. So we need to find the different angles. The equation of trajectory is y is equal to x tan theta minus g over 2v naught square sec square theta. I put the value of y, x, right, and the value of g and velocity. I get the relationship of this. And this is tan theta, this is sec square theta. This is the trigonometric equation that you have learned in your previous classes. That this sec square theta, I can convert sec square theta into tan square theta by putting 1 plus tan square theta, right? So I put 1 plus tan square theta, and this equation is being converted into the second order trigonometric equation. Tan square theta minus 6.524 tan theta plus 2.96 equal to 0. To make your calculation easy, I put y is equal to tan theta, y square minus 6.524y plus 2.90. This is simple algebraic quadratic equation. I solve this, I get two values of y, and of course these are tan theta, and take the angle, and this one angle is 80.6 degree, and other angle theta 1 is 26 degree. So at a lower angle, this one is 26 degree, and this is about 80.6 degree. Thank you. I hope you understand how to solve these problems in a projectile motion, and this will help you to solve other problems. So please solve problems from the book related to this topic, and this will help you in solving this.